So I found out I was coming to this conference probably on Monday, and Candace and I were talking about, well, I'm already in Austin, even though I work for Stanford University, and she couldn't make it yesterday, so it'd be great if I could come up on Thursday and kind of hear the conversations that were going on, and then fill her in so she could present her keynote on Friday. And then last night, when the ICE was happening, I thought, I realized there's another purpose for my being here. So thank you all for allowing me to speak on Candace's behalf. My name is Zimmaro, and I'm a senior researcher of learning assessment and analytics, newly of Stanford University. About 3 months ago, I joined Candace when she moved over to Stanford. And prior to that, I was at the University of Texas at Austin, and I know there are some colleagues from UT Austin here as well. And then I was there for 10 years working in psychometrics and assessment and faculty consultation. And before that, I was at Penn State University working for the Schreier Institute for Teaching and Learning. So I've had about 15 years of consulting with faculty members around measurement and assessment issues. And so there's going to be an assessment slant to my talk at the end of this. But I will also give you some of what Candace had hoped to present today about the work of the Open Learning Initiative that is now at Stanford University. And then I will do my best to try to answer your questions as best as I can. And if I can't answer them, I'll make sure to bring them back to Candace, or we can have a group discussion. And I'm sure there are enough experts and opinions in this room that we can talk about where this is headed. So the presentation title is Surfing the Tsunami. And I kind of get the joke that Candace was going with on this presentation. But I realized I'm starting with 3 strikes against me. So the keynote speaker is stuck in the Dallas airport. It's right after lunch. No presenter wants to go right after lunch. You've all just had your tiramisu, and there's no coffee, so drink up lots of iced tea. And then we've ordered up this nice Texas ice storm, so I know some of you are frantically trying to figure out cabs and airports. So I will, and because I'm doing this on the fly, I didn't get to plan all those cool jokes that presenters have in their speeches and presentations. So I'll do my best to make this entertaining and engaging for all of you. Candace does send her regards. She's frustrated that she got here, landed at 11 a.m., and was stuck on the airplane for over an hour because she couldn't get into the airport. And then once she got into the airport, the cabs aren't running. So she does send her best, and I will do my best to represent where she's headed. So John Hennessy in 2012, he's the president of Stanford University, said, "There's a tsunami coming. I can't tell you how it's going to break, but my goal is to surf it and not just stand there and get hit by the wave." And so what is that tsunami that has hit us all since 2012? Well, the Open Learning Initiative started about 10 years ago at Carnegie Mellon University with funding from the Hewlett Foundation and other granting agencies, and they were trying to deliver online learning at scale. And at scale at Carnegie Mellon, about a decade ago, they were delivering courses to 400 students. And the tsunami that hit in the last year or so has been, obviously, MOOCs, and giving education at scale to hundreds of thousands, and not just in the United States, but globally. So what is the Open Learning Initiative, and how is it trying to respond to the tsunami of delivering education based on learning sciences at a scale that's not in the hundreds or thousands, but tens of thousands? So the Open Learning Initiative is based on the integration of technology and science of learning with teaching. It is designed to simultaneously improve our learning and facilitate learning research. So these are all critical components of what the Open Learning Initiative is trying to do at Carnegie Mellon and what's being transferred and worked on at Stanford University as well. So the premise, one of the main premises of any Open Learning Initiative course is goal-directed practice and targeted feedback to enhance student learning. So part of my role at Stanford is working with community college faculty who are building workforce and college readiness courses that are going to be made freely available to anyone who's interested in using their course materials. And this is a Department of Labor grant, and every community college in the United States, or every state, has received one of these Department of Labor grants, and the courses are going to be available within the next couple of years. And so I'm working with faculty members not just to design content, but to think about ways in which we can build interactive activities, create targeted feedback, and do things like cognitive tutoring to really scaffold students' learning, and then also collect data to inform the science of learning and engage in some research. And so this is an example of, I don't know how well you can see this slide, where a student is in an engineering statics course, and they provide a numerical response, and then they get feedback about that particular answer. That's not quite right. And so it's in the upper left-hand corner. And so these are not assessments that are only multiple choice questions or true-false questions, your typical online assessment items that we're seeing. These really are meant to be interactive, engaging activities that addresses common student misconceptions. And so taking this example, they have various activities called Did I Get This? And Learn by Doings, where students actually practice and engage with the material. So this is a question around force. And it's asking, the first question is asking, what is the magnitude of the sum? So students are able to ask for hints, and there are multiple hints embedded in these activities. And so this particular hint is saying the purpose of the activity is self-assessment, so you should try to work through it on your own, but if you can't, you can ask for another hint. And there will be multiple opportunities and scaffolding that occurs throughout the activity. And then finally, it would show various steps as a part of the scaffolding process, and the student may or may not get the item correct. In this case, the student finally answered the item correct, and it says, great job. Now try another item on your own without asking for hints or the scaffolding. And the premise of the interactive activities that have been built in the Open Learning Initiative is cognitive tutoring. So it's a computerized learning environment based on cognitive principles that is intended to target student errors and answering questions about what to do next. So imagine your student, if you teach a course in your office hours or with a TA, and what the process would look like if you were tutoring them through answering a problem. Well, we're trying to replicate that in an online environment to really address those misconceptions and provide the scaffolding needed so students, when they do get stuck, get feedback about what they can do next rather than just keep repeating or going back to the text or videos. And there are various tutors that have been built in the OLI courses over the years. There's a logic proof lab, a causality lab, a biology simulator, economics experiments, engineering, chemistry. They also have a statistics tutor. And the idea for these tutors is to practice synthesizing and applying skills and knowledge, again, with expert modeling about how to answer problems and engage in these interactive activities as the students try to work through the problem sets. So what are the affordances of the technology that have been designed and continue to evolve over time? So certainly 24/7 access, connectivity. Students can be connected to one another, to experts, not just nationally but globally. 24/7 access, anytime, anywhere. They can also do simulations that they might not otherwise be able to do in a face-to-face situation. They can build a bridge without worrying about it falling and people being affected by it. But the real advantage of the technology is what Amazon has discovered, and what Google has discovered, and what Netflix has discovered. And it's what we at OLI refer to as the killer app. And it's this idea of data collection, creating data collection to embed feedback loops for continuous improvement. And there's data collection that informs the student, how he or she is doing in the course, that informs the instructor, whether this is a completely online mediated course or used in a hybrid format. It informs the course design team. So there are cognitive scientists and human-computer interaction specialists, and assessment specialists, and project managers that are all involved in designing some of the OLI courses. And so how well are the various learning activities working? What modifications need to be made? How do we improve the course for other users and other instructors? And finally, data that informs the science of learning. What do we know about what students, how students learn, and how can we get better at replicating that using the affordances of the technology? And so I'll go briefly over some of the elements of the OLI design process that touches on each one of these. So in terms of student feedback, you already saw an example, a very brief example of some of the kinds of targeted feedback and hints that students can get as part of the interactive activities. And so the OLI system records interaction level details that the student works through the module and provides immediate and targeted feedback to the student. So this is not a matter of an X or a check mark or correct or incorrect. We actually work with authors to identify what's the misconception that's happening when the student makes an incorrect answer or types in a wrong number, or they have some short answer responses as well. So what's that misconception? What would we do? What would you tell that student if they were sitting with you to address that misconception to help them get the problem right? So we have data that informs the student about how well they're doing. We also have data that informs the instructors about how well their students are doing. So the Open Learning Initiative courses can be taken asynchronously by students anytime, anywhere, but instructors can also use them for cohorts if they want to use it in an online format or, again, in a hybrid format. So an instructor following a cohort of students that he or she is teaching would have access to a dashboard. And one of the main elements of OLI courses is that they have semantically tagged content aligned with learning outcomes. And learning outcomes are further broken down into sub-skills. So if we're teaching, my background is statistics, so if I'm teaching a statistics course, I can say one of my learning objectives is student understanding about descriptive statistics. And then I might want to know sub-skills about do they understand mean, median, and mode. And I would have the dashboard be able to identify how well my students in my class are doing based on the overall learning objective as well as the various sub-skills. So these bars, I can see the first learning objective. The bar is primarily green, meaning most of the students that have attempted that problem are getting it correct. Gray indicates that some of the students in the class haven't tried the problem yet. Yellow bar means that there's a prediction that students are struggling with the concept, and then red indicates that there's a problem. And there are some predictive models behind the learning dashboard using some Bayesian analysis of knowledge components, and I'll talk a little bit later about the Pittsburgh Science of Learning Center that works with OLI to do some of the modeling behind the dashboard. So instructors can also drill down on a specific student. So each one of those dots represents a student response to a particular learning outcome. And so I can see the number of students that are struggling in a particular area or skill. And then I can also drill down on that student and see what his or her responses are and how they're doing on other learning objectives and sub-skills as well. So in addition to the student and the instructor, OLI data also informs the course design team. And so the design process for Open Learning Initiative is one that's a community-based design process. It involves learning scientists, instructional technologists, project managers, universal design for learning, which deals with accessibility issues, software developers, instructional designers, and assessment experts, I would add to that, domain experts, and then also the user experience. And so after every course is completed or for cohort-based or at various snapshots, they can see how students are performing on the various learning outcomes and skills and get data about which questions are working well, which skills are being assessed. So maybe the activity is not doing very well in terms of assessing the students, or there's a particular activity that could use some enhancements. And so the column with the blue bars is a measure of average help needed. So that refers to the number of hints that a student has asked for in a particular problem, plus the number of incorrect answers on that problem as well. So I can see near the bottom there are two items where students are asking for a lot of hints and or getting the item wrong. And so is it a problem with the item, or do we need to provide some more scaffolding and instruction around those particular skills because students are struggling with it? And you can see also in the red, it's showing that 17% and 20% on their first try, how well they're doing on that particular assessment item. And these are broken into interactive activities, and then they're also, at the end of modules, there are higher stakes quizzes. So you can look at how the activities are helping to support learning, as well as a more summative assessment and see how students are doing on those as well. So I should say, in terms of forming the course design team, there's a review with the instructor of the course, but then also across multiple instructors and multiple courses. And the course design team looks at these data to see what activities need to improve and how well they're working. And finally, the science of learning. So I mentioned the Pittsburgh Science of Learning Center. 10 years ago, it was given a $50 million grant from the National Science Foundation, and it developed the LearnLab. And the goal of the PSLC was to look at technology-enhanced courses, conduct assessment, and do research. And so it requires cooperation from schools to share their data with the PSLC. They have opportunities for researchers to go in and access publicly available data. So some researchers are making de-identified data available. They also help support some of statistical and predictive modeling behind the scenes for some of the learning dashboards. And so LLI has partnered with PSLC to do some of the learning dashboard and the modeling that you saw presented earlier. And so one of the outputs from the PSLC is what they call learning curve analysis. And so on the x-axis, those are problem opportunities. So from 0, this particular learning outcome had 42 different problems associated with it. And then the y-axis is called the assistance score. So again, the number of hints plus the number of incorrect answers. So when students are first attempting this particular learning outcome, you can see at the beginning they need a lot of assistance and or they're getting the item correct. But over time, as they get more practice with that particular learning outcome, the learning curve shows that they need fewer assistance. Their assistance score goes down, which indicates levels of learning around this sub-objective. And they use learning curves, so if there were a spike in a learning curve, it could be that there are actually 2 skills being assessed on the problem sets. We often see leveling, plateaus, where learning stops, and then we need additional scaffolding to increase learning. And so this is also part of the data that is used to inform the learning of science, or the science of learning. So in summary, OLI applies learning science research and scientific methods, and I'll talk a little bit about some of the studies they've done, to course development, implementation, and evaluation of what works. They develop interactive learning environments collaboratively in the design team process that I showed you. It creates feedback loops for continuous improvement to students, instructors, the course design team, and the science of learning. And then also creates communities of use, evaluation, and improvement. And so the instructors that are using the OLI courses are participants in the evolution of what has worked and not worked over the last 10 years in improving the course design. So ultimately, what difference has this made? What has the research shown over the last 10 years? So there's been 2 studies, both of which, or the first one of which Candace was involved with, around accelerating student learning. So in the first one, it was a study of their introductory statistics course where they had students take the introductory statistics course online in a 6-week condensed format, and a traditional course taught by the same instructor face-to-face over 15 weeks. And they found that on a pre-post test, students in the accelerated course did better than the students in the in-residence course with the same instructor. And I believe the in-residence students had access to the materials from the OLI statistics course but weren't required to use it. So OLI version 1.0 was sort of the first decade of the work that had been done by Candace and colleagues at Carnegie Mellon, and there were some limitations to the work that they had done. So there are Creative Commons licenses for the course material, but it was on a closed system. So if you wanted to create an OLI course, you had to contact OLI and work with their course designers. There were no authoring tools, and that you have to be accepted as a part of the OLI design process in order to use the system. There were limited, if of any at all, authoring tools and adaptation tools. So once the course was built, it was pretty static. We couldn't modify or change content without a lot of work. You saw the dashboard in its current state. So there's limited visual representation for data-driven improvement. And there was no student dashboard at the moment. And so that's one of the things I'm actually working on is enhancing the current dashboard and thinking about how to do student dashboards in terms of how do we get data at various levels into the hands of the instructors and students in real time. It was focused on the individual learner rather than groups and cohorts of learners. So we have no characteristics about how different students learn in the various OLI courses that we do have data on in some of our MOOC courses. And primarily STEM courses were the content that was built in the OLI. And we know that the technology will afford opportunities to go into other disciplines, but the OLI courses from Carnegie Mellon, a STEM-heavy university, was what version 1.0. So as I mentioned, Candace recently moved to Stanford, and so we have our team called OLI at Stanford working on some of these issues. So what's next? So the idea is to do both design-driven and data-driven course improvement, and so thinking around design-driven models with cognitive science, thinking through metacognition, issues around identity and mindset and how students are engaged, and creating testable hypotheses about what works and doesn't work in an online learning environment, but then also using the data to inform our explanatory and predictive models around using data mining and statistical modeling. Some machine learning and artificial intelligence projects are coming to bear as well. And then bringing subject matter expertise to bear to the whole phenomenon of what are students doing and how are they learning in an online learning environment. And also, Stanford has a partnership with edX around Open edX. And so several months ago, prior to my actually even starting there, I think Rob might even be in the room, Stanford downloaded the Open edX platform and has been working to deliver some of their hybrid courses through the Open edX platform and is making contributions to some of the development work that's happening to the actual platform and partnering with Google and edX and other folks across the country to think through how do we create an open source platform and how do we provide hosting opportunities so that it's not that closed system that OLI was, but is an open system that institutions who are interested in using it and or individuals who want to contribute to developing the platform can do so. And our particular role on the OLI team at Stanford is to take some of those elements of OLI courses and embed them in the Open edX platform that don't currently exist. So targeted feedback and interactive activities, there are foundations for those, but we really want to enhance that, taking the learning dashboard that's already there and creating a more robust instructor dashboard, creating student dashboards, and then also working with experts in data mining and cognitive science to create the predictive and explanatory models that are behind the scenes helping drive some of the data-driven improvement. And then we're also working on open data and data formats, so the idea that there would be a share alike and share data licensing agreement doesn't exist, but we think it should. And we really want to work to build and promote communities of research, both at, not just at Stanford University, but with partners, and I know I've had conversations with several of you while we're here, and if you're interested in thinking through some of these issues with us, please let me know, and I'd love to connect with you. And I should mention there are two data jams. There's edX Harvard Data Jam that's being hosted, sponsored by the White House and Department of Education. That's going to happen next week. And then the end of next week, Stanford is also hosting one. And one of the topics is data structures and data privacy issues. So we're trying to think through how do we create, and I know there's some work, Una May O'Reilly's been thinking through some of these issues as well, some of you here as well. And so we're trying to bring leaders and thought leaders together to think through how we might create common, share the data so that we can inform students, instructors, design teams, and the science of learning. So a little bit of an assessment spin. I mentioned my background is in measurement and assessment. So bear with me, and I'll give you my spin on where we're headed with MOOCs and online learning. So the design process, course design, educational technology, we collect some data, we analyze data, and refine learning theories and our models. So that's been a pretty common process in my work, whether it's online learning, face-to-face, hybrid learning over the last 15 years. So in terms of course design and educational technology, there are some critical course design elements that we see emerging, particularly around online learning. We've seen content chunking, whether it's video segments or expository text. The cognitive scaffolding that has been demonstrated by the Open Learning Initiative has been shown to be a critical element in supporting and using the technology to support learning in ways that we might not be able to do in face-to-face formats. Those interactive activities with targeted feedback, I think, are at the heart of what we really can use the technology to support effective course design, to really use online learning to enhance what we're doing with our students. The hints that we provide, so again, modeling that cognitive tutoring, so you're stuck, what is a hint, how can we help students figure out how to solve the problems, and then finally learning dashboards, feeding back data to both instructors and to students, making them consumers of their own learning. So in terms of the data collection process, I mentioned that the OLI espouses the killer app with student learning data at the center of that killer app. So my question is, how do we know we have the right data to inform the feedback loops? So in terms of learning assessment design, we need to ensure that we're creating the right activities, the exercises, and the assessments that are aligned to learning outcomes that reflect the kind of learning we want to capture. So bad data in equals bad data out. If we're asking low-level questions, or we're building our activities that aren't engaging student learning at higher levels, then the data that we capture and the claims that we can make about student learning are going to be limited. So I mentioned that I've been consulting with faculty members for several years now, and in my experience, this is typically what has happened as we've evolved into technology-enhanced course design, and whether it's in a hybrid or completely online. So we spend a lot of time on technology production. And then maybe about 50% of our time there. Maybe another 40% is on the content. What are the words that we want to say? What is the expository text? Maybe even making the videos, writing the scripts for the videos. And then how we're going to assess whether or not students are effectively learning in those environments is sort of tagged on at the end. And oh, yeah, that's right, I have to think about how to assess my students and whether or not they've actually met those outcomes. And we're not, I think we need to flip some of our design process and really focus on what we want students to be able to know or do or demonstrate, and then how are we going to assess that they've been able to meet those outcomes, and then what are the activities and what is the content that we need to share with them to get them the learning that they need in order to demonstrate those skills. So it is all about the student learning. That's really our goal here, and what we're trying to do. MOOCs have afforded us the opportunity to expand our reach and our audience, but ultimately, learning does result from what the student does and thinks. And the teacher can only advance learning by influencing what the student does to learn. So in an online environment, we need to replicate the idea of the apprentice and the expert tutor in an online environment, and then figure out how to assess what the students are actually doing. So this whole idea of authentic assessment at scale, we were talking about at lunch, at my table, we were talking about online counseling programs. And so the idea of how would you deliver an online program about counseling individuals, and what would authentic assessment of their skills in an online environment look like? And I think this is one of the challenges as we move forward. We can do content delivery at scale, but can we do authentic assessment at scale and do it well? And yesterday in Jeff's talk, I wrote down this quote because it struck me. The biggest innovation in higher education is competency-based education. And I would agree with them. But I also think one of the biggest challenges in higher education is competency-based assessment. And how do we signal to stakeholders the learning outcomes that students have met? And earlier this morning, I went to a presentation on credentialing. So imagine trying to assess the students have met their competencies and then also certify that they've, and credential in our current higher education system, course credits, competencies, whatever unit of assessment of learning that we want to define it as. But figuring out this challenge in an online environment at scale, I think, is one of the one of the frontiers for exploration in the next few years. And technology and assessment, just like with learning and content delivery and access and affordability, technology also enables learning assessment that wasn't possible a decade ago. We've got machine learning and artificial intelligence. We can do interactive activities. We can do cognitive tutors. We can give targeted feedback immediately as soon as a student responds to a question. They don't have to wait several days to get that kind of feedback. But it also has its own unique challenges in terms of security. So in our credentialing presentation, we talked about proctoring exams and biometric analysis, with ProctorU and video cams. So how are we going to do assessment at scale? How are we going to know it has evidence that it's valid for what its intended purpose is? And how do we do this at mass? So I think technology-enabled personalized learning assessment is the new frontier. So how do we assess students? How do we give them personalized learning tracks and learning paths? Because we can use the technology in ways that, and to do things that we can't do in a face-to-face environment. So how do we use the affordances of the technology to push the frontier around assessment and around learning? So that was sort of, what do we do to collect the right data? And then once we have the data, what do we do with it? So there's easy to get data versus what might be a little bit more hard to get data, but potentially with greater impact. So I've seen presentations around what I call event data, sort of logins, time spent, click streams. Easy to grab. We've got programs that track and capture this. A little bit harder to capture is performance data, but still typically involved in some of our LMS systems and our MOOC platforms, percent correct on items, course or certificate completions. And then the real challenge, and I think one of the foundational premises of LLI, is outcome data, where we have assessments linked to specific skills and knowledge components, and we can target student misconceptions and identify misunderstandings, and then provide interventions based on those misunderstandings. So the data I think that's going to give us the greatest impact is outcome-based assessment, but it's also the greatest challenge to do at scale in an authentic way. And then also, what do we want to do with the data? So prediction versus explanation. I think we're getting pretty good at doing prediction. Students with certain characteristics, we've seen if they engage in the first 3 weeks of the course, they're more likely to complete a MOOC than those that don't engage within the material in the first 3 weeks of the course. But what does course completion actually get us? Versus, can we understand and explain where students have misconceptions and create targeted interventions at those misconceptions? So I think, I know we're here at this MOOC Research Initiative Conference to try to get at some of these issues. And this is, I think, our prediction models and our explanatory models. We're thinking through the right questions, and now we just have to figure out how to get the answers. And finally, refining our learning theory and our models. So our 20th century learning science and engineering and assessment was based on intuitive design, and unfortunately in the 21st century, we are moving towards evidence-based design. We had isolated development, and we're now moving to community-based connected development. We were sort of flying blind in the 20th century, and now we are data-driven. I think our challenge is to sort through which data is most impactful and make sense of it. So it's not lack of data, but actually making sense of the tons of data that is around us. And oversimplification around learning science to managing the complexity of what we know about how students learn. So some of the research possibilities that we've seen at OLI and I've seen today, identifying valuable research questions about online learning environments, creating a community of researchers, both locally and globally. We can't do this alone or isolated anymore. Performing top quality research with platform and learner data, engaging in the largest possible discussions about online learning. And I think today is a great example of what we're trying to think through around these research possibilities. So to sum it up, the title of the presentation was "The Tsunami is Coming." My question is it a tsunami that's coming, or has it already hit and we've just now at the tip of the iceberg? So in terms of what we know about our own learning and how students learn, and what we do not know about how students learn. So we are just at the tip of the iceberg. I think in terms of the Open Learning Initiative, the various MOOC platforms, and the researchers that are in this room, I hope that we can push the envelope and continue to think through ways in which we can help support all of our learners, our lifelong learners, and students in various traditional university settings and everyone in between. So I do want to acknowledge the funders of the Open Learning Initiative. I mentioned the Hewlett Foundation, Bill and Melinda Gates Foundation, Lumina, Kresge, the Walter S. Johnson Foundation, and the Spencer Foundation, and then the National Science Foundation for funding the Pittsburgh Science of Learning Center. So with that, I will do my best to try to answer your questions.
Thanks, Dawn. I'll bring a mic over there, so if you can just...
I have one question, and you showed some analysis, the learning curve analysis that you showed. So that learning curve analysis, and you had 40 or 42 points going across. Okay, so are they from, is that, I'll let you bring it up. Okay. We thought we lost internet. So the question, you have these 42 points. Are these 42 points across various assessments on that skill or objective? Okay.
Yep.
Now, here's the other question I have. Is it on a single item that you have that go across, or is this a couple of items, you know, on that skill that you feel the student should be at this point in the course than versus this point or this point later on in the course?
So are you asking, is it a single item that we're using to represent a skill in each of those? So those are 42 problem opportunities.
Okay.
And so a problem, there could be 5 or 6 problem opportunities embedded in an interactive exercise. It could be a single standalone item as a sort of a did you get it activity.
So these all map to this overall objective. Okay, let's say the objective is you add numbers.
Correct.
Okay, so let's kind of give an example. You add 2 numbers, and the first problem is, you know, do 1 plus 1, 2 plus 2. Okay, so you get that one. Okay, let's go higher level and let's do 2 digits. You're trying to see if that student is grasping that concept.
That's correct.
Okay, so the other question
this would be a particular learning outcome that would be pretty complex. 42 problem opportunities for a student to do addition. You wouldn't need necessarily 42 items to do that, but a higher, more challenging learning outcome might have multiple opportunities to practice.
Okay.
And so there are activities called Did I Get It?, Learn by Doing, and quiz assessments. So part of the premise of OLI design course is that you get multiple practice opportunities.
Okay. Okay. All right. Thank you.
Sure.
Time for 1 or 2 more questions. Anyone?
Oop, over there.
There we go. All right. Meet you in the middle.
Hi. How are you?
Hi, Rob.
I was really curious about what the sigma improvements were. What can you say statistically, you know, about students coming into the STEM courses and the likelihood that on any module, if they took that module, they would see an improvement if they first asked for a hint, or if they subsequently failed the question. What would be an abandonment rate without the just-in-time answers or just-in-time assistance versus the assistance that the OLI system was able to provide? Can you give us a statistical picture of that?
No, unfortunately I can't. But I can address what because I actually don't think that the question that you're asking is being answered by the data analysis yet. So the question was, do we know if a student asks for a hint? And every response that they give automatically provides targeted feedback. So if they provide an incorrect answer choice, then they get feedback about whether, as they select a choice, they get feedback about the correctness of that answer choice, regardless of whether or not they ask for it. And so the question is, if they ask for a hint versus hint seeking, which is modeled as an incorrect answer, versus they just got the incorrect answer choices, what's the statistical effect behind that? I don't know enough about the OLI data to be able to answer that, in all honesty. But I don't think that modeling has actually been done. And so, did you have an answer to that, George? Oh, okay. Yeah, I don't think that actually has been done. I know they have looked at the effect of help seeking, because that was one of my questions. Why is a hint actually treated the same as an incorrect answer choice? And they have shown, the models have shown that it predicts why students, you can explore why students ask for hints, but that it actually is the same as an incorrect answer choice. But I don't know enough about that research, and so I wouldn't want to misstate anything.
Have you built any of the OLI adaptive functionality into any MOOCs at Stanford yet?
No.
Are you going to?
We hope to. Whether or not they will be Stanford delivered courses, I think would be up to the faculty members teaching those. So the courses at OLI were built by teams of subject matter experts, a lot of them which were at Carnegie Mellon, and we want to do more community-based development and then also expand. One of the challenges of OLI, I think, has been adoption and use. And so whether or not Stanford faculty members will adopt these courses, I'm not sure. I think there's interest there.
Okay, we have time for one quick question.
I'm wondering if you have built in anything in your research to look after retention of student learning. So they've taken an exam, they've done all the adaptive learning, they've passed, they're done. How long does that information persist with them? Because that's one of the challenges that I have with courses. They don't really persist for me.
So I believe that research has been done on the introductory statistics course, which is the most popular OLI course, and they have shown, so they did pre-post test and then they did a second post test after a period of time, and I can't quite recall what that period of time is. And if anyone's interested in the research study, I'm happy to give the link. But they did find long-term retention, better long-term retention for the students who took the OLI course than the students who took the in-residence course. Again, in that one particular context.
All right, well, thanks very much, Dawn, for an excellent presentation and for taking it on such short notice and doing a fabulous job with it. So thank you.
Thank you
Please
all.
join me.
Appreciate it.